Today we want to look at similar shape in mathematics. When photographs show same picture but different sizes, we say that the pictures are similar to each other. Example, look at what we have on the board. We have two squares. By measurement, we were able to establish that the length here, the length of this one is what? 8 cm, while the width is 8 cm. Here, the length is 4 cm and the width is what? 4 cm. So you can see that they are similar. The squares are similar. The difference is that this one is smaller than this one. So we say that the two squares are similar to each other. So we can find the ratio of the longest side to the shortest side of the square. Let's do that for the large square. For the large square, we have that the longest side they are the same. The sizes are the same. The length is 8 cm and the width is 8 cm. So that is the reason why I said the longest side is 8 cm and the shortest side, which is the width, is what? 8 cm. So, and then now 8/8 is equal to 1. Then for the small square, we have the same thing. The length is 4 cm and the width is 4 cm. So we have 4/4, which gave us 1. So it means that the ratio of the length to the width is 1 for the large square, and for the small square, the ratio of the length to the width is 1. You can see that they have the same ratio. Okay, in that case, now we say that is the reason why we say that they are similar to each other. Now let's do the same to the triangle. For the triangle, we say that the longest side by measurement is 6 cm and the shortest side by measurement is 4 cm. For the smaller triangle, the longest side by measurement is 3 cm while the shortest side is 2 cm. Now let's find the ratio of the longest side to the shortest side. For the longest side, we have 6 cm over the shortest side, which is 4 cm. So, but this can still be reduced. 2 can divide 6 and 2 can divide 4. 2 divide 6 will give us 3 and 2 divide 4 will give us 2. Our cm cancel cm. So we have 3/2. This is the ratio of the sides of the longer side to that of the shorter side of the large triangle. Then for the small triangle, we have that the longest side is 3 cm while the shortest side is 2 cm. Nothing can divide here. It cannot be reduced further. Cm can cancel cm. So that we have 3/2. You can see that the corresponding sides are in the same ratio. That is to say that the longest side for the big triangle, the large triangle, is 3 in terms of ratio, 3:2 for the shortest side. Then for the small triangle, the longest side is 3:2. 3:2 for the shortest side. That is the smaller triangle. You can see that the corresponding sides are in the same ratio. What do I mean by corresponding side? You can see this side here corresponds to this side. This side, this longest side, corresponds to this side. This shortest side corresponds to the shortest side. You can see that they are looking exactly the same. This here is looking exactly like this. This one is looking exactly like this. This one is looking exactly like this one. So that's why we are saying that they are corresponding to each other. Another thing is that by measurement, This triangle here is 90 degrees. Here is 90 degrees. Here is 30 degrees. And here is what? 30 degrees. Here is 60 degrees. And here is what? 60 degrees. You can see that this angle corresponds to this angle. This angle corresponds to this angle. And this angle corresponds to this angle. So because the corresponding angles are equal and the corresponding sides are in the same ratio, we say that the triangles are similar to each other. Now, let's consider these triangles on the board. This angle of the bigger triangle is 30 degrees. Here is 60 degrees. Here is 90. For the smaller one, here is 30 degrees. Here is 60 degrees. Here is 90. So we say that these triangles are equiangular triangles. Why? This is equiangular because we can carry this one, the small one, and fit it into this one exactly. You can see how I turn this one, fix it inside this one. The angle of this one here, this angle here is equal to this one, and the angle here is equal to this one. That's why it's exactly fitted in. Are you getting it? The angle here is equal to this one. I can turn it in any other way. If I decide to fit it here, I can carry this and fit it, and this place will fit exactly here. If I decide to fix it in this side, here will exactly fit into this place. So you can see that if I decide to fix it using the 90 degrees angle, they will fit exactly perfectly. If I decide to fix them with 30 degrees angle, they will fit perfectly. If I decide to fix them with 60 degrees angle, they will fit in perfectly. And when two triangles can fit perfectly in this way, no anyhow you turn it, we say that the triangles are equiangular. With this, we can then say if this larger triangle is labeled A, B, C, and the smaller triangle is labeled K, N, M, we can say that AB corresponds to KN. AC corresponds to KM. DC corresponds to NM. MN corresponds to CB. MK corresponds to CA. I hope what we are doing is understandable. Now, consider the triangles on the board. We have triangle XNT, triangle YPM, triangle ODB, triangle OZW. Now, find out, state and write them down, the size that corresponds to each other. I give you an example. XN corresponds to YP. Then go and finish it up and hand in.